Co-founders of a company called Fiume, which I believe means river of knowledge in Italian.
You're stealing some of my talk,
Sorry. They previously also headed up the data science lab at Clifford Chance and have an amazing range of experience in machine learning and engineering as well. So I'll hand over to them now. Thank you.
Thank you, Tasha.
This way. Cool. Okay, hi. Thanks for coming. Appreciate all of your attendance. So welcome to this evening's edition to Data Science London. We're going to be talking about how we've succeeded in industry with data science initiatives. And with anything that we're saying, please either shout out or ask questions at the end. We want it to be more of an open discussion about what we're doing and how we're applying all of this stuff to industry. So the generic corporate spiel. Yes, absolutely. Yeah, sure. As long as it's my good side. Yeah.
If we look good, it's fine.
You can just like the other side. There we go.
That's fine. If the beauty filter is less than 6, no. Other than that, it's fine. So, hi, we're Fiume. As my shield has been stolen, the word in Italian means river, and we're kind of inspired by that fact or the association with, the river of knowledge, all of that good things. It makes branding really easy because you use blue and you use images of water, and it's all really good. But basically, as a company, we are focused on delivering AI and data products for our clients and our partners. One thing that's very important to us is the concept of self-sustaining. So we want AI initiatives to pay for themselves. We want things to effectively prove themselves. There's a lot of misinformation in the AI and machine learning world where effectively we want to provide real value with AI and machine learning products, and this is what we're trying to do with Fiume. Check us out online, add us on LinkedIn. It would be really nice to have more connections, all of that stuff. That's why we're doing all of these talks. So a little bit of introduction about myself. I'm Michael. Hi, nice to meet you. I've been into tech from an early age. My mum loves to talk about a story where I went into a bookstore, I think at age 8, and walked out with a big fat Java book with a UFO in the front. Sat down and learned it. I was like, yeah, I really love computers, it's great. And since then, being a software engineer, done all of this, and then when the whole data science machine learning came out, it was like, well, this really interests me, but I'm not that good at maths. So the whole machine learning, data engineering stuff really resonates with me because it's very, very important in this space, and it's starting to finally be recognized in terms of data science initiatives, but it's not traditionally associated with data science. This is my colleague Mirko.
I'm Mirko.
No.
I'm not Michael. Yes, my background is more like computer science and data science, compared to Michael. I had the opportunity, and honestly I consider myself lucky, because I managed to build 2 data science labs, one in the publishing sector and one in the legal sector, was all previously before chance. Like Michael, I have a passion. In my case, more like around how you can use the academic methods and academic research in order to succeed inside the industries. This means making some modification about the type of methods and applying best practice in order to deliver something in production. I get back to Michael now.
Oh, sorry, I just realised my mic wasn't on, so if nobody can hear me, then I'll speak louder. But essentially, what we want to do is introduce our protagonist for the speech, which is Mario. No connection to Mirko, may or may not be Italian. Mario has the unfortunate distinction of working for F Corp. Maybe if you're sort of a Facebook farmer, you might recognize some of these images, but effectively this is Mario who works at F Corp. He is a data scientist. So what are Mario's challenges? Well, as a data scientist at F Corp, he works with budget limitations. He may not be able to have access to the things that he wants because F Corp may or may not be stingy. It's often difficult to go into production due to the difficult nature of AI in corporations. He may not have the assistance that he needs in order to help get him there. There also might be a general sense of disillusionment with AI. Maybe they failed before, maybe they're not really too sure what AI is. you know, it's a general mistrust, misunderstanding of actually what Mario is doing. He may potentially work in an environment where there is a rigid tool selection. He might not even have the permissions on his laptop to install Python. Like, you know, it's hard to work in a corporate environment. Also, he may be considered a dreaded member of IT. The final common challenge is access to data, and probably everybody here recognizes that that's a really, really difficult challenge, especially as a data scientist within an organization. So, what does Mario need in terms of doing his job, turning up every day, being a data scientist at Evercore? Well, so firstly, he needs access to data sets. I mean, data scientist, data sets, makes sense. Part of this is security clearance. Is he allowed to work with this data? Is he meant to see this? Are the right permissions in place? What is he meant to be doing? Is he allowed to do this? I mean, it's quite fundamental. The second is in terms of data pipelines. Does he have access to things that will allow him to do his job in a scalable way? F-Corp has 124,000 SharePoint databases. Is he able to ingest and work with that data in a realistic way? Finally, F-Corp, from Mario's perspective, needs to understand that he is not bringing them any risk. GDPR is a common issue. Are they going to have to pay a £30 million risk for the work that Mario is doing? Is it worth it? If we can address all of these issues, then we start to have usable data that Mario can use to work and do his job every day. Secondly is compute power. Data science is hard, it needs big fancy machines to do stuff. So we need to be able to spin stuff up on demand. If any of you has access to sort of like a 32 GPU, TPU cluster, please tell me. I'd like to come and work for your company on premises, that's wonderful. But, you know, the high compute power, GPU, TPU of all of this stuff, it's expensive. So effectively, Mario needs access to these things to make sure that he is capable of doing his job. But then there's also an issue from F-Corp's perspective of cost control. I mean, if Mario makes a mistake and his algorithm runs for 2 weeks on a 32 TPU cluster and it costs him £40 million, it's going to be an issue. So he needs to ensure that he's working in an environment that isn't going to spiral out of control and he's comfortable and confident in what he's doing. If he gets that, then he can start to do some proper machine and deep learning on the usable data sets that he's got. Next, we have some model pipelines where the development lifecycle stuff, coming from a software engineering background, is very important to me. Git commits, pull requests, code reviews, that's all great. That's where I live. That's what I want to do. I want to make sure that my colleagues, and Mario wants to make sure that his colleagues are okay with what he's doing. Then there's also the concept of MLOps, which is effectively DevOps for machine learning. I don't really need to explain too much of it to you, but it's very important that Mario lives and works in an environment where this is lived and breathed. Not only enforced, but, you know, this is what people do. They understand what it is, what it involves, how to use it. We also need some kind of production monitoring to understand exactly how this stuff is being used, where it's going wrong, how everything is being effectively worked within F-Corp's production environment. As part of that, and Mirko and I have come from a legal background, we need to be able to audit this stuff. We need to know what is done where, with who, by what, with whom, loads of W's. You know, it's very, very important, especially if somebody external comes in and says, well, can you explain why you did this? Who did what, when? What we get from this is updatability, quick development, effectively iterative, agile ability from the model pipelines, from the machine learning aspect of Mario's work. So to achieve this, effectively we need to bring the business, or as we describe it, Shaggy, as part of the team. It's okay to have business relationships with your data scientists, with your data team. You know, I mean, there's nothing weird in 2020 about having a weird shark husband relationship with your data scientist. That's okay. And it's kind of important because what we need to consider is that Shaggy, as the business, is able to remove Mario's budget limitations, or at least define them, so that Mario knows the environment that he's working in. It's really, really important that Mario knows how much, how little, whatever he can spend to try and approach all of these data science problems. Communication with the business is a huge issue. especially when you're coming from a data science perspective where people may not even really know what it is. So you need somebody as part of the business to be able to talk to your other parts of the business, effectively removing the communication obstacles that may block you from talking to subject matter experts, to really defining what you're trying to do, trying to deliver. Prioritizing data science initiatives is a very, very common challenge that data scientists, data engineers, machine learning engineers face in F Corp. How do they know? How does Mario know that what he's doing is being prioritized by the business? How does he know that, oh, okay, well, we've heard of data science, let's just say we're doing it? How does he know? Shaggy, as part of the team, can help him do this. It also gives him confidence that the work he's delivering and doing is really important to F Corp, because, you know, as an intelligent, skilled person, Mario needs to know that because, you know, he's Mario. It's very, very important to him. It also provides an escalation point for him in order to say, well, I'm not getting the help that I need. I'm not being provided with either access to the right people, the right data, anything, to then being able to do my job. There's nothing more frustrating than sending an email, following up 2 weeks later, sending an email, following up 2 weeks later, sending an email. Can I have a meeting? Oh wow, I scheduled this meeting 3 months in advance and now it's been cancelled on the day I was meant to have it. You know, theoretically, this is what happens, but in practice, actually, it's incredibly frustrating, especially for really clever people like Mario, to feel like they are not being included as part of the business. So this is why we need to have Shaggy as part of Mario's team. Finally, there's the concept of onboarding other teams. This is twofold. Firstly, it's to understand that Mario is part of the wider business, part of wider F Corp. But then it's also to understand from the business perspective what Mario does, what he's delivering, what his unique selling point is. Why is F Corp doing data science? It's very, very important to onboard the other aspects of F Corp so that they're all working as part of a unified team. From Shaggy's perspective, I mean, what is his motivation? He's the business. He effectively is motivated by maybe 1, 2, 3 things. But when he starts to look at Mario's work from his perspective, what he can see is that we get a cost reduction from maybe man-intensive, labor-intensive works. We get improved performance. We potentially can increase revenue depending on how Mario is working. But then also, where Mario is really interested in is creating new revenue streams, because he is applying effectively new things to an industry to create possibly new lines of business for F Corp. It makes him very attractive to Shaggy, but then it also increases the likelihood that Shaggy and Mario will work together as part of a unified team. But how exactly do we make this work in terms of the unification of Shaggy and Mario, in terms of a profitable AI initiative? Well, everything starts with an idea. You really need to have an understanding of what you're trying to achieve, what you're trying to do, what are you using all of this data for? Well, you need some kind of governance related to that, which is about innovation. You need to determine if actually this is just some random stuff, or if it's actually valuable to the business. This is where innovation and the innovation pipeline comes in. With Shaggy and Mario working together, they can potentially develop AI products. This is where real value to the business comes. From the AI products, that's where you start to get this return on investment, which generates revenue. The whole point of this very simplistic but idealistic diagram is that from this return on investment, we start to get revenue for Shaggy and the business. What that means is this can feed into the new idea generation, but then it can also feed into the existing ideas, so that effectively these ideas become self-sustaining, they become self-supporting. Effectively, you're proving that your AI initiative is profitable. What this also gives you is a level of confidence with the business, so that you can start to achieve more, you have less suspicion, you start to address some of the challenges on the earlier slides where Shaggy and the business are not necessarily quite sure what you're delivering, or what Mario is delivering as part of the business. So, quick survey. What should Mario's team deliver? Where in the triangle? I mean, as Shaggy, you want to deliver in time, on scope, and in budget. But that's not realistic as part of, any approach. This is how business sees things. You need to have this impossible triangle of everything. You define up front what you're trying to achieve, you set goals, you design for 3 years, you create for 4, and then at the end of it you've delivered a banana. And you're like, but the business doesn't want a banana. This is completely irrelevant to what I'm doing. There's no business involvement in what you're doing, there's a lot of administrative overhead. Basically, Mario is becoming a project manager when he wants to be a data scientist. So, what we are saying is effectively approach AI initiatives as products. So this is the lean startup, MVP, agile approach, where effectively you're iterating constantly, success is motivated by business metrics, you're getting feedback from the business continuously with either user adoption, revenue, cost saving, you're delivering in iterations, more creativity, more releases, you're finding out from the business what they actually want. You're not spending 7 years making a banana when they're sharks. Sharks don't eat bananas. That's right, isn't it? Yeah. So, the whole product thing leads to more creativity, more releases, less waste. And so, effectively, what we're saying is products are good. So, create AI products, not projects. Good? Yeah, makes sense. So, what is an AI product? Well, everything starts with data. Data Science London meetup, pretty simple. In an organization, you need a layer of governance. Effectively, we want to make sure that we are doing the right data with the right thing, the right shape, with the right people, all of that stuff. We don't want to get sued. From this layer of governance comes our data pipelines. Machine learning engineer, I love being able to process 100 billion rows a second. All of that stuff, effectively, we have repeatable, reusable pipelines where we can shuffle out huge disparate data sources into something usable. From the usable data, we get a subset of that, which is training data, which then we can pipe into our training models, our algorithms, our actual models. The key takeaway from this, though, is that models are very important. But Shaggy doesn't know how to use a model. There needs to be an application wrapped around this. There needs to be something that Shaggy can use as a shark. He only knows how to use web services, he only knows how to use APIs. Something needs to interact with these models so that Shaggy can use them. From this, we get value, we get return on investment, and we complete our cycle where effectively these AI initiatives are starting to prove themselves, they're starting to pay for themselves. The business is understanding what we mean by profitable AI initiatives. So all this is great in theory, and I'm talking quite quickly, but F Corp is a traditional business. They want to be competitive. They may not really even understand what it means to move an idea into production. A lot of people in the tech space don't really even know what that involves. Can I use my Python notebook? Maybe not. But the fundamental thing is, a lot of the time there's confusion on what data science actually really is. Is it food? Yeah, we don't know. But then if we consider from Mario's perspective, he might be the only data scientist within F Corp. That's a really hard hat to wear because a lot of people expect a lot of different things from him. How does he deal with that? From F Corp's perspective, they are trying to understand how they pay for Mario's bills. How do they pay for his really expensive TPU cluster that suddenly cost them 20 grand? That's an expense. We are not expecting that. But then also we need to consider how do we align F Corp's perspective, F Corp's objectives with Mario, because as soon as he's not engaged, as soon as he's not learning something, he's going to be looking for another data science job. There are a million of them, his skills are quite rare, so how do you enable Mario to firstly do his job, but then how do we keep him interested? This is one thing that we love to present. This is our AI journey or maturity curve, where it consists of the foundations and the productionization aspects of an AI journey. Everything starts with a vision or a goal. We need to really understand what we're trying to do. The good summary of this is we want to build products to sell services. I'm F Corp, I want to do this. Great. So how do we do this? Well, we need to have the concept of an innovation lab. This could be a theoretical lab, this could be a bunch of people in a classroom wearing white coats. It doesn't really matter, but effectively you need a layer of determination about the vision and goals to determine, is this okay? Is this valid and valuable to the business? Effectively, we need to determine the most valuable idea from the ideas and goals, the vision and goals, in order to progress. Next, we need a tech adoption plan, because you can't just slap a new technology in front of, let's say, a lawyer and expect them to use it. They've made more money today than they had yesterday, so why are they interested in Mario telling them that he's got this new fancy technology? It's not realistic. You need to have a plan for how this technology is going to be used and adopted within F4. Next, we need to introduce cloud services, and if you disagree, please speak to me afterwards. But data science is not possible without cloud services. I'm sorry, but you can't scale, you can't automate, you can't do all of the things that are fundamental to the cloud without it. Again, you know, if you work for a company where you've got a huge on-prem budget, please come speak to me, but it's foundational to the success of AI initiatives. Once you've got that, then let's start to get some software as a service with AI in it. Let's try and introduce the concept of AI to a business in a nicely, easily run package so that they can start to understand, well, actually, this isn't a magic box. If you put bad stuff in, you get bad stuff out. If you don't train it, you don't get stuff out. It starts to introduce the fundamental concepts of AI to a business, and you get immediately actionable insights so they can start to really get to grips with what AI is. Next, you need big data. You need to be able to collaborate all of the disparate data sources that F Corp has in their 1,020 SharePoint databases to actually do some advanced analytics to get some insights across a huge, huge, huge set. Cool. So next, what we want to do is probably introduce AI as a service. Cloud provider of choice, anybody?
I mean, you're in Microsoft, so...
Azure? Cool. So they have Azure Cognitive Services. They have some great stuff in terms of entity recognition, language detection. I didn't say anything, so it's fine. Language detection, image recognition. They got a load of stuff that you don't need data scientists to actually get some immediate results. I mean, it's pretty cool that I can call an API with a bunch of stuff and get stuff back. It's really, really good. And in terms of quick turnaround to deliver something to the business, that's really, really impressive. We could stop there, but actually where Mirko and I want to bring people to, and where we want to bring Mario to, is research realization. Effectively taking latest scientific research, come from people's PhDs, really, really clever people that I don't really know what they're talking about, realizing them as AI products. This is where we want to be. Effectively, what you get is a 5-year competitive advantage because it's going to take PhD student X 3 years to develop a product around his PhD research. It's going to take him another 2 years to productionize that research to be able to work with corporations. If F Corp gets Mario to introduce that kind of concept, they effectively get a 5-year advantage ahead of their competitors. They start to get really, really, really advanced with just following the maturity curve. And I know I talk a lot, but I'm not just making stuff up. Mirko now will actually talk about some real stuff where we've actually done this stuff.
Thanks, Michael. So, second part of the talk is a little bit more technical, finally. We're going to introduce use cases that is part of a wider product that's been delivered in for chance. We can speak freely because the specific has been published in a scientific paper and is public domain. Then I'm happy to speak about which is the paper that is behind and what is the business need around it. Problem is document classification and legal. More specifically, why we're looking at document classification and why in legal. Legal as an industry, they have this type of things called repapering. What does it mean? If you are a financial institution like a bank and so on, you know, by that time to time, some governments change the law for whatever reason. It can be Brexit, it can be IVOR, etc. Changing the type of legislation, it's mean for them, look, I have, let's say, 500,000 or 1 million of documents that can be loan, can be agreement of different type of party. They have to go through all this document, understand which one need to be repapered. That's mean changing some specific laws inside the document. and then wrap again and say, okay, now it's ready, and move to the next one. The challenges, as you can see, for my rates, okay, looks a nice problem. There is a lot of big data here. Let's see what is a document and how shape it. Oh, crap, a document is not one file, because often it's a set of files, because maybe it's a loan running on for 10, 20 years or more. Then you have annex, you have extension, you have many different variations of that. And my client does give me a folder called a document, and I'm not dealing with 500,000, 1 million of files. I'm dealing with millions of them, maybe 10 millions. Okay, let's see how this file looks like. You know, data scientist, I want to do some analytics first. Oh crap, these files are at least 100, 200 pages long. We're not speaking about an IMDb review. It's massive. So, okay, nice. And let's see what we have on the research space, and this is why, for example, we were looking to create a paper in the beginning. It's a little, because long-length document classification is not really a common use case in the research area, especially for the classification. Usually, if you use BERT or similar type of models, you have a limitation on the length that you can put inside the model. And it's not ever close to 5,000 words and more that we are speaking in this one. From Shaggy perspective instead, why he's looking for that, okay, we spoke about. Definitely he needs to improve his team performance, because he might have this new fancy client that's asking our paper exercise. Then you adapt, I cannot really do it manually, it takes forever, it will be crazy expensive. And they have a legal deadline that they have to stick with. We're speaking about cost reduction, because we are trying to remove manual labor, essentially the annoying things to open the document, understand what it is, catalog, and go somewhere else, in order to streamline later which specialized lawyer can do what. Because if I know exactly the type of loan, I know exactly which lawyer I need. And potentially speaking about the type of loan, not if it's a loan or something else. Then we are really looking on the subtleties here. And we're speaking about an increase of revenue, because I'm able to do a new type of task that I wasn't able to do before. And on top of that, more important for Shaggy, I have a reputation improvement. Where in the legal space, it is made a reputation is the core business. Reputation improvement is mean, oh, I get recognized as an expert in AI. This means as a business, I can do and pitch something else to someone else, some other clients, and they will listen at me, because I can show, oh, I have this set of paper published, I went to this set of conference speaking about this topic. As to your data scientist, you see that I know what I'm talking about. I'm not just inventing something on the field. You see, thumbs up, we can move forward. What has been done at the time, what we did, is, as you can see, apply the scientific method. But that's what you can do. There is some piece of research that we carry on, then you know perfectly how it works. But this one is not enough in the specific. Why? Because like Michael was saying, as a concept, you know, only the model, Shaggy doesn't care too much. It doesn't see the real value to having a model in a Python notebook that ends there and say, okay, nice F1 score, cool, and what I can do with that one. He wants to see that specific running on his business process, on their lawyer, on when they start to do the real job. And this means applying also industry best practice on all the different areas related to this type of work. Let's go for the funny part. You know, like any data science effort, you start to look at the data first. That was an interesting challenge, because the first point is we don't know what will be the client. Okay, then we cannot really assess the type of document we are dealing with. It's going to be American English, US English, it's going to be loan. What we are talking about specific is related to text, and you know, there are so many variations. You change a legal firm, it changes completely the template, I mean how the clause has been written. Then there are a lot of challenges just around that. What we end up is to choose the US Security Exchange dataset. It's called Edgar. It's open. You can go there, download as many documents you want. You have something like 20, 30 years of documents there. That looks great because it's mandatory in US, and every company need to pay the taxes or do an acquisition and so on, they need to go through that specific process. This means exactly what we were looking for. We have a huge variety about a different type of industry, and we can just bring for free. Yes, looks great. An open source software called OpenEdgar that we streamlined in Kubernetes in order to scale and be able to download quickly 15 million of raw documents. This application, connected to the web service on the US Edgar project, was able to download also a lot of metadata that will be already handy on the next slide. Plus the documents. The documents, they were really a mess because the concept of filling is a huge text that contains a lot of stuff inside. If it's a PDF, it will have base64 encoding and so on. Then you end up to doing all the type of work that's been done in Databricks around document analysis, cleaning, text extraction. Not only for doing the basics, but also because you discover that, this guy did a filling, cool. He took some kind of, word conversion, something similar, and he uploaded also JavaScript. He uploaded also images. So I'm interested only in the text, and now I have to deal with all these kind of things and filter correctly. Then for 15 million, essentially quickly, we end up to choose around 30,000 of documents that has more than 5,000 words, not characters. We're speaking about hundreds of pages here. Everything was run in Microsoft Azure. Then, we are fine with Microsoft. No complaint there.
Yes, we get to stay.
Yeah, we come back.
This stuff is coming from the metadata that we collected during the OpenEdgar phase. Essentially, every filling has associated type. We chose this 5 type because we were interested to having 5 balanced classes, completely balanced. 5 classes of 5,689 documents each. The perfect scenario to do the training. And we're looking, okay, this is cool. We want to make a little bit more hard for all models to work. Then we added this guy here, Exhibit 99.1. That doesn't mean anything to you. When we discovered what we were thinking it's perfect. Because essentially, it's just a label to say, whatever thing is with this label can be everything else. Then you may have exhibit of this type inside here, because it's an additional exhibit for investors. Then it's perfect. It's creating some kind of bias, creating some noise. It's more similar to a real-life scenario where maybe the documents are a little bit messy. On top of that, we had another layer of cleaning because we noticed immediately, look, there's some of this filling that have always the same header. I don't like that. If you put the same header, of course I'm going to specify correctly. It becomes trivial. And that model I'm using, it looks at the first page, job done, and we just cut that page. Because we like to make things a little bit more similar to the reality. Removing a page is not a problem. We have hundreds, then no one will notice that small difference, except our models. What we did as a next step was, okay, how we can deal with these huge documents. We tried different models, we tried different approach. We worked for some months around the type problems until we had an idea. What if we got more like inspired from how the voice algorithm are dividing their weight in order to identify words when someone is speaking. Essentially, what if we divide a document in chunks, and on top of these chunks, we figure out how we can merge everything together, and then do the classification on top. Based on this concept, we say, okay, this is essentially the novelty inside of work. We created multiple models, and we end up to choose 2. And to compare these 2 with the 2 like inside the paper. How it works? The first one we call the linear classifier. Also, it's not really only a linear classifier. Let's see. Yeah. Okay. The first step on top, on the left, you get the document. We divide it in equally divided chunks. Okay. After that, we apply doc2 back in order to have a set of embeddings. Now that we have this set of embeddings, you can see like a kind of synthesis of that specific chunk. We created deep learning network that is used by LSTM, attention, and then in the end, batch normalization. You know, sometimes you have a problem when you use LSTM and so on, because the one machine gradient type of problems and so on. Then with batch normalization, that problem more or less disappeared completely. And what was the meaning to using attention by LSTM? It's simple. We were looking to have a synthesis from that set of embeddings that is focused only around the classification. As you are aware, when you play with attention, you have LSTM that has a memory, then you want to focus that attention only on the things that really matter. What does really matter for us is classifying correctly. Then this is what we end up to get on the last layer of embeddings. Then in order to do the real classification, we use the classic linear neural network, and then, as usual, softmax. And then you have to have your classes and your probabilities. This is the first model. The second model is a kind of simplification of the previous one, still for proving that that type of architecture was working better than Dog-Back, especially when we use the chunkings. And after the last layer of embeddings, we use a straightforward SVM classifier. How it looks like in practice? Like that. First, these are the results. The models, you can see model 1, model 2. This is the number of chunks. We arrive to 50 chunks. When you get more than 50 chunks, it takes really long to do hyperparameter optimization. Each one of the steps we were playing with hyperopt and so on in order to go through all the different steps of optimization and be sure to get something that was good enough. I would like to point out that the word count here is an average. When you go 50 chunks, you still have 500 words. You know how many are 500 words in a text? It's still a lot. To be a chunk is still big. And these are the results. We'll show you test and validation in order you can see the comparison on what we trained and what we get with a data set that the model never seen before. As you can see, it's worth it if you compare to one chunk to doing the chunking. You have an improvement in performance. After a while, you have a degradation. And of course, we are always looking around 1%, 2 percentage point. It's really a small type of improvement. Why is like that? First of all, we're speaking of 97, 98. They cannot get 10% improvement, it would be more than 100, that's smart. And second, only having 1% of millions that we classify, it's worth. Because if you divide 1 million by 100, still a lot of documents that are carried on correctly, essentially. And for all lawyers, mainly going a lot faster anyway. Oh, this is a bit smaller, but okay. This is showing you essentially this group here, the same chance model 2, that is essentially the best result score that we get maintained at 11. How it looks like on a confusion matrix. Why? Because we want to see for bad guys, the exhibit 99.1, how it's behaving. It's behaving exactly as expected. It's saying the model is still good enough, but we get a peak of 50, 10.1 that has been classified as exhibit 99.1. That makes sense given what is the meaning of that specific type. It contains other subtypes. Then of course you have some noise. Let's see the comparison now. How we can represent a comparison that is nice to see, especially in presentation. Just play with TSNA. This is the vanilla Dog-Back. As you can see for the TSNA, we have we have some nice grouping around. They are a little bit close, fine. The red one is always the bad guy that is trying to beat anyone else that don't for the word, as usual. But when we move on the new model, you see that the grouping are a little bit more separated each other. It's very clear. It's a kind of TSNA diagram that you all love always have as a result. And the red guy is still trying to come with the word, but hopefully it's not really achieving his goals. Saying that is the result of the paper, you might ask yourself, how did I manage to increase the business to sponsor completely a paper without involvement of university or anyone else. It's been fully based upon the company where I was working. From my perspective, it makes sense. We're speaking in a space where there are not so much academic research, then it's easy to snake a paper there, it would be good. Almost all the documentation you find is always about short documents, because the open data set usually used are papers. Okay, there's a lot of text there, it's for free. EMDB review is a classic one, yield review, Twitter and so on, still short text. Then again, is another good reason for moving forward. We believe that we got some good results on your work, then also that one is a good point in order to move forward. But if I do this type of conversation with Shaggy, I say, sorry, I'm not interested. Why I should care about this academic stuff? Then we flip the coin for Shaggy in this way. Dear Shaggy, what do you want? Oh yeah, if we do that, you can start to get recognized as an expert. Like I said, improving reputation is really important, and give you new business. Then yes, I'll make your life a little bit easier. Being an AI expert, it's cool also to put in the pitch and put in the website and so on. And you can prove it because you can link on something that is more official than just a white paper. And last but not least, it's more easy to hire some good data scientists because we get some kind of name inside the community. You can find the paper online and so on. This is all paper essentially. There is no one from academia, it was everything from Clifford Chance at that time. You can find on our Receive, it's the easiest way to get there. And you can find all the detail about the work that we carry on there. So in conclusion, before going to questions, just to summarize this long pitch, what we did in the past in order to succeed in Clifford Chance and in the public sector before is following these 5 basic principles. The first one, you need to work in a agile environment, you need to bring the business with you. It has to be part of your team. Otherwise, you don't have anyone that is opening the door that are always closed. Like, I have a problem to speak with the security team, or the infrastructure operation is not going to help me on that specific. If you're the business that has the money, has the power, that thing is solved in 1 day or less. And definitely, it's a huge help in order to get to success. Then another important point that you always have to keep in mind, you want to assess your maturity inside your company. Why? Because if you know your weakness and you know where you are strong, it's more easy to move forward. You know where it makes sense to invest. If you have maybe a headcount, you know if it's best maybe to invest in a DevOps, also if you have an infrastructure team there, because maybe they're not at that level of maturity, they're not there yet. They will be there, maybe in a while, but you need today, not yesterday. Then you start to move on the right way, we start moving the right step for your success. Have a product mindset, I spoke a lot of chat before about that, that's very important because you have the business with you, and you want to show him the value of your work. You're expensive at the end of the day. All the tools that we are using are really expensive. I have no idea how many hours that we spent. I don't want to know it because I would have an heart attack. But they were totally fine because they saw the value on doing that work and they saw the value on having that paper. We get an article on the legal press around that paper that for them is invaluable. And this is why they open the pocket in that way. Another really important thing is always try to get for the real meat. Always try to implement the most basic problems. How you know that? Take your business, ask how much is worth this idea before I start to think about it. And if you get there on the step 1, how much you get as cost reduction, as revenue, depending on which field you are working for. Because only if you know that type of data, you can drive your decision correctly. We had as a data science lab, and I was there at data science lab, question, can you please create this fancy dashboard? When I asked what is worth it, the answer was, oh, this will help the CEO. Helping the CEO doesn't have any value compared to helping a couple of partners with a very crazy rate per hour. You know, the CEO is getting paid by the partner in our case, then I prefer to help them because that help will give you immediate money, it give you immediately revenue. Last but not least, always apply scientific method. You already know how to do it essentially, and especially using industry best practice around the life cycle and lots engineering and so on so forth in order to move forward quickly. You always want to control what is the status of your model production, and you want to have the ability to quickly turn around and to change or challenge the status quo in order to improve that specific. So this is us. Q-code is LinkedIn. Go to contact, no problem. Questions? Yes.
So, how did you adapt that production line against the model? Yeah, internally for the company, was it some sort of a what type of product did it turn out to be, or was it just one-off project?
No, it's not a project. It's a kind of internal platform for the delivery of the papering exercise. You know, that type of exercise is massive for a financial institution. Then on the other side, from the legal firm, is massive as a revenue that you can generate when you sell one of them. And of course, you need a lot of personalization. Then it's part of the platform that they are using for with pitch, getting the job, and after it's going to be slightly personalized for each one of the different clients. Then the trick, as always, is try to get the production as quick as possible. Mm-hmm. The one on the paper, it's one reality that is used as, you know, parallel universe in order to push that type of concept and get a huge visibility inside of the sector and the press, especially for this type of exercise that are really big, let's say. But in reality, the model that they're using inside the platform is slightly different. It's working well, but we went to production as quick as possible. This means first iteration is in production. Okay, it's not perfect. It's already better than doing that work manually or using a standard clustering algorithm that you do not exactly what is picking up, and you have to spend more time to analyze everything.
And you had to present it in court to justify the results of the algorithm.
No, why I should?
So it might be that you classify a million documents, identified 5,000 to be presented in court. The judge might want to know what was wrong.
This is not related to court. Sorry, my mistake. This type of work is not related to court. This is for the papering exercise. This means that they say that you have a big corporation, you have 1 million of contracts signed across the globe, okay, written in English or different languages, doesn't matter. And there is a change in the legislation, like GDPR or something like that. Then you have to go back on your contract and change some clause there when it's necessary.
Yeah.
Then there is no court there because not always the work that the lawyers does is related to court. Often is, you know, they're far away from the court. Sometimes they're trying to avoid it. It's only one sector that is called the litigation that they're dealing with that type of issues. So other sector in the legal world, they are not usually dealing with the court.
So we did deliver some projects that were actively used within that type of scenario, but one thing that's very important to always remember is that we're not trying to replace lawyers, we're not trying to offer legal advice, because that gets us into a whole other world of pain, and we don't have enough money to be able to defend ourselves in court about that. There is always a human interaction point regarding any output produced by these systems. This is augmenting human expertise, it is not replacing it. So we're not trying to suggest that we are making legal decisions or legal advice based on the outputs of these models. It's very, very important to recognize that distinction, because otherwise we are going to be bankrupt. It's difficult, but one thing that lawyers are always asking us, especially when we do these presentations, is, well, when is your machine going to replace us? And it's this sort of casual conversation saying, well, we're not trying to do that. What we're trying to do is help you do actually your clever lawyering better. You don't need to read these million documents. We're going to identify the 10 that you actually need to look at, and then use your clever lawyering to address that.
unless you miss one.
Are you a lawyer?
So if you said I only have to look at 10 and the 11th is the one that the contract actually comes in force.
Certainly, but then it's quite an interesting concept because, especially working in industry with all of these concepts, we have delivered solutions where within 2 weeks of development, we have an 80% accuracy. We have proven that the manual process has at best 60% accuracy. And do you know what the first question people ask us is? Why isn't it 100%? We can objectively prove that this thing is better, faster than what you're currently doing, and the initial suspicion is, well, actually, why isn't it perfect? And this is kind of a lot of what I was talking about, how you need to manage expectations. You need to actually work with the business to let them know that what you're doing is an augmentation to their process. We're not claiming to be perfect. We are literally presenting to the 2 decimal points what we are doing. It is then up to the business to work with us to manage risk, work with Mario to manage risk and do all of that. It's far outside Mario as a data scientist scope to be able to manage all of that potential risk. What we are doing as data scientists, data engineers, machine learning engineers, is providing potentially a better way of working. We need to then work with Shaggy to how we can integrate that.
That's just trying to understand your data analysis part. You get the data and then you process it.
This one.
Yeah. So in terms of document analysis and text extraction, so it's just doing the unsupervised learning and then just doing the document classification.
No, this is just in order to have text, usable text for whatever algorithm you're looking to use. Essentially, the system, the Edgar API, they provide you something they call fillings. A filling is a huge file that contains multiple documents inside, multiple files. You have some metadata around them. It's not an XML, it's not any kind of standard format, it's a standard Edgar format. Okay, it's completely different than anything we ever seen. And then starting from there, you need to apply multiple transformation in order to have a text file that is clean, that is everything in Unicode, that you don't have strange character, that you can process quickly, and there is the information you're looking for. For example, you have to answer a question like, how I manage when I get a table? Shall I keep all the text, or shall I ditch some of this text because I'm not interested in this exercise? Or I keep everything, and if I keep everything, and which format am I going to keep everything? If it's some other format, you maybe have some character set that need to be converted, because maybe it's coming, it was an HTML embedded inside a kind of text file called filling, and you need to convert all the type of character in something that is usable on the other side. All that type of work that you need to carry on in order to get just some text, including analyzing PDF and so on.
Yes.
So if we go back to the concept of an ad hoc AI product, we're not even in that. This is literally the pipeline stage. We're not even getting into the fancy AI machine learning stuff. This is literally preparing a bunch of really not very well edited data to something that we can throw into a model. This is trying to highlight the incredible effort that it takes to take any realistic data set to become valuable to import into something.
So this is not your model, but
This is certainly
This is engineering.
Yeah, so this is to sort of to productionize even just the downloading of these 15 million documents. I mean, if you want to do this in sequence, it's going to take you a year. But just sort of creating a container, doing all of this multiple pools, dealing with the concept of restriction on the SEC database, all of this, it's a challenge in itself. And this is not the machine learning AI part. This is the data engineering, machine learning engineering, the data engineering part of this. It's basically trying to get a bunch of stuff that's really badly formatted into a format that we can put into a model.
Like when document analysis, you want to create some histograms and say what is the variation, what type of format you're dealing with. This is what, for example, you consider PDF. How many do we have inside this 50 million? How many crap stuff that might be because it's JavaScript. I don't care about having code specific. All that type of analysis that you do on the data, on the raw data, in order to drive your next decision on how to proceed. This is why you have this 4 steps, essentially, this kind of the 4 steps that we went through already high level. We start from around 50 million of raw documents, then you start to redefine, removing all the garbage that you don't want, and it becomes essentially half. Because there was some kind of standard application that was used for sending the feelings to the system, but they were adding a lot of JavaScript and so on. And we have a lot of files that are just completely irrelevant to remove. And then from 70 million, do more analysis and see, for example, how I can get something that is usable, that is clean, what type of file types I want to keep, etc. It's essentially data analytics plus engineering.
Okay.
And this is kind of the thing that justifies my job and my existence. I don't know the model stuff, but to get the data in a format that clever people like Mirko and Lulu and the actual smart people can do, it's a job in itself, I mean, it's not fancy maths, but it's not easy.
Yeah.
Yes.
How did you deal with false positives?
False positives. That was easy to spot because it's something that we get thanks to this guy here. Second slide here showed that these types, they were coming because the metadata associated to the feelings that were coming from the original system, and we didn't have to do a manual classification. Then the false positives, they were correct ones. If you don't have a bias or any noise coming from the data set, that was a great situation where to be. And when we end up, let's say, to create all the different confusion matrix, was easy to spot and try to see what was happening there. We did so many different iterations here, like to clean up false positives, false negatives, and so on. This was what we did here. We have to use this one as well, like 300 on the tails. And then we had the ability to look at details on the single documents and see, okay, who are exactly these 5 guys, and then try to understand what's happening there. Of course, picking some random between the diagram and one is always helpful. 5% random. This whole is possible. Yes?
After you published your paper, did you see other legal firms doing the same?
It's doing, sorry?
After you published your paper at the first chance, did you see other legal firms doing the same thing?
So this was published in what, December or January?
No, December.
Yeah, so no.
Oh, really?
Yeah, so this is
like
very fresh.
Startup, you started last month.
No, our company has been born 3 weeks ago.
If you've got any contacts for us, please. But no. What we have seen within industry is that there is a lot of, I don't want to say fakery because I don't want to get sued, but there is the image or the perception of what they're doing is AI machine learning, and we, as let's say industry professionals, understand that they can't really actually be doing that from what we understand about their business. In terms of producing a paper of this caliber, certainly nobody. We definitely expect this to happen. There are a number of progressive legal firms, law companies, which aren't legal firms, which we certainly expect to follow suit. But certainly this is, with however you want to word it, the first scientific paper completely sponsored by a legal firm.
And we saw an increase of legal firm looking to hire data scientists. It's 2 years now that they created that Science Lab in for chance, and they did a lot of talk. We went also Spark AI and so on. And we gradually saw, like, especially in 3-6 months, that they start to hire data scientists, and they're gradually trying to create a data science lab, especially the big ones, the ones which is simple. And if you are good in that big, would be like a nice opening, because they have a lot of Yes.
So, yeah.
So,
Just to pick up this confusion matrix, if one of the categories was a catch-all, why does it only confuse two of the categories?
because it's not completely catch-all. It's might have some catch-all inside. It's as definition of the type. It's part of the fuzzy things that you have on this type of problems. This additional exhibit for investment companies, it means that they can attach annual reports as an additional exhibit for investment, maybe from another company. It's not mandatory that it's taking one of the other fillings, but they can do it.
Okay.
It's the only field, that essentially you have a lot of noise coming. And this is why it was so interesting to have that specific here. Yes?
Yeah, I just wanted to ask what was your data partition strategy for your training and validation? So 50.
5 balanced classes of 5,689 documents each one. Essentially, each of the classes are completely balanced. We didn't try to do unbalanced learning with all the problems that come with that sector. Because we were trying to verify if that comes about, okay, what's happening if we split a document in chunks when it's so big, it's still worth, and how we can deal with that complexity. That is the focus of the paper, essentially. Yes?
Hi, thanks for the talk, really. I'm curious, it seems like you've ingested a huge amount of data here. I'm wondering whether it's got more value, whether there's some sort of high-level features of your learning model that you could apply to other text classification problems that aren't specifically these groupings around legal documents. Maybe there'd be UK financial classification.
So I'll let Mac answer most of it, but one thing to understand about the Edgar database, and especially in the legal space, is that we can't overstate the difficulty of getting a huge amount of non-classified data to work with, especially data that we can stand up in front of a room of people and talk about. And so certainly the development of the model, the insights related to that are applicable to other data sets. But it is incredibly difficult to find a raft of information that has the similar structure to, let's say, legal documents, legal contracts, which we can then firstly publish in a paper, speak publicly. I mean, legal firms are crazy.
That's sort of what motivates my question, because you've managed to get this huge data set and do all this processing of it. I'm just curious whether you could then utilize some of the more embedded learnings of your model to then train other types of classifications of legal documents that may not classify to these specific